voltage system, and in our group we have Katie, Kevin, and Micah. And I will be presenting the FOPDT modeling. Basically, the outline today, we're going to be system overview, basically the background of what we've done so far, description of it, of our voltage system, SSOC, step response, and then follow up with FOPDT theory, model of the theory results, and then end with a conclusion. This right here is a schematic. You have your voltage transmitter and your recording controller, and this is the control actuator, which controls the motor, which generates and dumps the load into a bank of light bulbs. This right here is a block diagram. We have the manipulated input, which is the amount of power, percent of power being put into the motor to generate into the generator system, and then output, which is our control variable, which presents us with voltage. This right here is a steady state operating curve. We did a range from 65 all the way to 80% input, but the part that it's all steady state. The part that we found most linear was to be between 67 to 80% input with an output of 10 volts to just before 70 volts. Right here is one of our step ranges from 65 to 80% steps, a 15-step height. And as you can see, right here in this area, to where it immediately steps up and then gradually increases. So right here, it automatically increases. And from here, again, we got our tau, our dead time, our delta M and delta C, and our slope of our graph to get our FOPDT parameters. In here is the experimental averages that we got of the three parameters of FOPDT. We have tau, dead time, and the gain. And this is for all of our ranges up and down. And as you can see for the gain, basically as the step height increases, the gain decreases, and as the step height is smaller, the gain is higher. But within the tau and the dead time, it pretty much fluctuates in between, and it has some bar graphs to show for this. This right here is for our three ranges: 65, 70, 75, and 85% step height, a 10 and a 15%. And we have the step up and step down with our error bars in it. And as you can see for the gain, I think I said backwards already. No, I didn't. As for a smaller step height, you see the gain is higher, and then it slowly decreases to where, for the down direction, we found it to be fairly similar. Again, average dead time pretty much fluctuates. For the 10% step height, we barely had anything. And here for the tau, we saw that as the step height was lower, that the tau was higher. As the step height increases, it decreased. And then again, with this step down, it pretty much fluctuated in between. Here again, the main reason for FOPDT is the three parameters: gain, time constant, and tau, which is tau and dead time, which are the three main parameters that we're looking at. Here in the model equations, we used, these are the two equations for the manipulated and control. This right here, just for the 65 to 80% parameter in the up and down direction, were the parameters for the model. This right here is, again, the 65 to 80% step range. As you can see, you have the experimental input and the model input, which pretty much fit quite accurately. And here with the model output and experimental output, we were to fit it as best we could. And again, you can see where you have that slight increase on the experimental output of where it jumps up vertically and then gradually increases. Here with the step down for 15%, again showing experimental and the manipulated input overlaying. Here is the model and experimental model of all the bar graphs for all three of our ranges for the 5, 10, and 15% step range. As you see, the gain was fairly accurate, except for the 10. Don't quite know why that probably didn't come out. Maybe in the human or calculator error. Then here's with the step downs, you have the experimental model averages right here, and they're fairly similar. Now, when we get to the times, especially with the average dead times, they pretty much fluctuate in between. Again, showing the experimental models in both the up and down direction for all three of our step heights. And this right here is the average tau. We did, however, get some similarities in the smaller step range, but once we get into a higher step range, it kind of fluctuates. And in conclusion, as Dr. Henry says, that basically what is our customer most concerned with, and we are looking mainly at the model averages. And again, we got tau, the dead time, and the gain. And again, you can see in the gain is that is highest when it's in the lower region. As it goes down, it pretty much decreases. Then the taus do show some variances in between. And this is, again, is because when we manually put in a slope and trying to calculate the dead time and tau, you have some variances with trying to calculate it. And that is it.